Voltage. Move the function selector to volts. DC volts is the default setting. To move to AC volts, press the mode button once. The voltmeter setting is the most useful, and all faults can be identified with the voltmeter and the LoadPro leads. There are 5 voltmeter readings you'll need to use: full voltage, normal voltage, low voltage, ghost voltage, and true zero voltage. Voltage is electrical pressure, so the voltmeter is essentially a pressure gauge. The voltmeter is the safest meter because it's completely passive and won't harm vehicle circuits and systems.
Okay, voltmeter. Here are the basics of the voltmeter. First of all, it's the meter you're going to use the most. You turn the meter to volts, it defaults to DC, leave it on auto range. Do not move it from auto range. Every reading you're going to take is going to be on auto range, okay? So don't go click, click, beep. No beeping, just clicking. Okay? Click, no beeps. Turn it to volts and leave it. It defaults to DC and auto, that's where it should stay. The manufacturer doesn't teach this way, but this is how I do it. Read voltage, push the button. If you see voltage, rule out opens and shorts. If you see loaded voltage, rule out high resistance. If the wire can carry a load with this button pushed, then there's no problem in the wire. That's it. That's how the voltmeter only system works. So now most people start thinking about, is it the component? Well, this process works backwards from that. I don't worry about the component, I worry about the wiring. Okay, that's my first concern, the wiring. So if I know the wiring is good, then it has to be the component. A voltmeter only system is a much more confident way to diagnose, because you're not predicting, you're not hoping, you're not guessing, your ego's not involved. You don't have to worry about the guy in the bay next to you is saying or thinking. You don't have to worry about that stuff. You just go read voltage. The problem with the ohm meter is you have to try and decide before you ever even start what the problem might be. Well, that's inefficient because you're never right. I'm never right. No one's ever right. You cannot predict what the answer is before you go out there and make some measurements in an effort to figure out what the problem is. And since 80% of all faults occur in the wiring, chances are you're going to find one of those faults when you measure voltage without a prediction. You don't have to predict anything, okay? If you don't read system voltage, there are 2 readings that you need to be conscious of. 2 readings you need to understand that you may never have heard of before. The first one is ghost voltage, okay? When the leads are not touching and they're wiggling around like this, okay? When the meter jumps, it's ghost voltage. Ghost voltage means you have an open circuit. So seeing voltage means you don't have an open, but seeing ghost voltage means you do. If the black lead is on ground, either in the connector or on the chassis, and you see ghost voltage, then some wire somewhere is broken. Well, if you see system voltage, you can't have a short to ground, because a short to ground would more than likely blow the fuse, but would also have a piece of wire touching ground. It would have continuity to ground, okay? So, exact same thing. If you see system voltage, it can't be shorted, but if you do have a short to ground, you will see straight zeros. 0, 0, 0, 0, 0, straight zeros. And it doesn't move. It locks in on zeros. This is 0, this is not, okay? So make sure you don't confuse them. Make sure you know these readings and make sure you understand them, okay? Now, the second step is, if you see system voltage and you load the circuit and the voltage drops, or if you see ghost voltage, you move the black lead to ground. When you move the black lead to ground, you remove the ground from the test, you repeat the test, and then you isolate it from one side to the other. think about this for a minute. If you repeat the test and the problem comes back, it has to be in the positive. But if you repeat the test and the problem goes away, it has to be in the negative. So, because what I'm about to show you is voltage drop across fuses to look for draws on the battery, okay? So all I have to do is take the fuse, put the meter on volts. It's on millivolts. It defaults in auto range to millivolts, okay? And I simply jump across the fuse in the small pins and sockets there, okay? And you have to grind in. You need to get in there. You have to push pretty hard. And notice that I've got 0.0, okay? Well, this means that there's no current flow because there's no voltage drop. And this is in the book, all right? So make sure you get in the book and you read this. If I go to this 20 amp fuse, grind in there pretty good, okay? I get 0.1, all right? It's not 0 though. So there might be something there. If I flip the leads around, if I get a negative number, then I know it's real. And sure enough, I know it's real. So that's actually a really, 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 really tiny, tiny current. And according to this, according to the chart, that's the IOD. And quite frankly, I don't even have a clue what the IOD is. Okay, I'm going to go to this 25 amp right here. Same thing, grind in, and I get 0, 0. I'm going to go to this 10. 0, 0. I'm going to go to this 20. 0, 0. So these fuses would not be the circuits that are killing the battery. Okay, well now this one does though. So if I swap the leads again, notice that I swap the leads and I get a negative number, so that is a true voltage drop. Okay, so this 20 amp has something flowing through it, and that something is the fuel pump. Huh, interesting. There's an itty bitty teeny weeny amount flowing through that fuel pump. Let me go to this 20 amp right here and see what we get. Alright, there we go. There's a number. And that number is 2.4 millivolts. Not volts, millivolts. 2.4 millivolts. And that tells me that something in this fuse, something in the circuit has got a complete circuit, and there's current flowing through this fuse. So if you had a battery that was dying and you were looking for draws on the battery, you wouldn't pull the battery cables off. You wouldn't, put your test light in. You just come out and read voltage drop across the fuses. Okay? Now admittedly, so it's these two terminals. I'm going to very confidently use my voltmeter. And by using the voltmeter, what I'm going to do is check to see whether or not I have voltage at one of these terminals. This is how the voltmeter works, okay? So the voltmeter, I would expect to read voltage across these two big main terminals here. And lo and behold, if I look down in there, I hadn't even looked, there's no terminal here. So obviously it's these two terminals. So now I've isolated it down. I got 4 terminals, 5 on here. We're only using 4. These are the coil terminals, and those are the big contact terminals. This is the starter relay. Okay, so I'm going to go to ground, and I'm going to read voltage here, and nope, no voltage there. But yep, I got voltage there. Now I'm going to load it, and it loads good. So everything from this terminal back to the battery is fine. Okay. Now what I'm going to do is flip it to ohms, because I'm going to assume that this terminal right here is going to go to the starter solenoid, which I'm going to assume is going to be about 5 to 10 ohms or less. It's even less. It's 0.5 ohms, which is really low, but it's not 0. Okay, 0.5 ohms is not 0. This is going to be the starter relay. Okay, so these two terminals come from. For the coil, one of them goes to ground and one of them goes to power. That one goes to ground, and I expected this one to be open because there's nothing there. Okay, but if I turn the key, that should go to 12 volts. So no voltage here. Oh, no, I was wrong. Voltage there, load it, good. 0.5 ohms here. So I'm using the meter. This is how I'm using the meter because I know how these relays work. So that means if I go to amps, I should very confidently be able to go to amps and jump from here to here, and it cranks the engine. One of the other questions I get all the time is whether or not you can use the Load Pro on 5-volt sensors, and the answer is yes. Okay? Let this record get out of here. All right, so this is a, accidentally on AC, that can happen, back on DC. This is a sensor, and quite frankly, I'm not sure what it is. Certainly something down here, but it's got 3 wires, and if I pull the connector off, it's got 3 pins, all right? Now, typically, you have voltage on the ends, and if I just go in and read voltage, I get negative 4.9, all right? So I'm gonna flip the connector around and read voltage here, and I get 5 volts, 4.9 volts. It's completely safe to now load. Let me get in there, make sure, don't, see, look, I screwed up, all right, and I dropped it, it came out, all right? Take your time. Don't be afraid to make a mistake. Be careful. I'm reading a good voltage there now, and if I load the circuit, notice that the voltage drops slightly, all right? What's the importance of what you just did? You just loaded the entire wiring harness for the power to this sensor and the sensor driver in the ECM. So if this sensor were creating a problem by simply reading the voltage, the 5-volt reference, and loading the circuit, you check the voltage, which means you don't have opens or shorts, and you then load the circuit, which means you don't have any corroded wires in the sensor. And back here in the frame, it's very likely that you can.